In this video, let us solve a problem, time series problem using ARIMA modeling. Time series. What is a time series? Time series is basically collection of data at a particular interval of time. It could be every year, every quarter, every month, or every day, or it could be every hour. So data at a particular source can be collected at a particular interval of time. So, what are the properties the data should have so that we can do a forecasting using ARIMA modeling? So it should have properties like constant mean over time, constant variance over time, and also constant correlation over time. So these are all the properties it should have. Then only we could make forecasting using time series modeling. So why it is required? These are all the properties. So these statistical properties makes easy to forecast the behavior of the series in future based on the past behavior of the series. So so these properties can be termed as a stationary. When the data is stationary, then we can do time series modeling. When the data is not stationary, we cannot make it time series modeling. If the data is not stationary, we could make it stationary by using mathematical calculations. So in this scenario, I have taken a data of births and deaths data from this location. So this is basically quarterly collected data. There are 4 columns in this: male live births, female live births, male deaths, and female deaths. So it's collected based on the quarter from 2000 to from 2000 quarter month. The data has been collected. So it has 52 rows and 5 columns. So that is the data set. It is in this way. So it is in the quarter. So in the time series, the property it should be a single column. It should have a single column, and the index of the column should be time. So the collected data has been converted into the time series model. In this example, I have taken male live births column for doing forecasting. So the plot, when I'm using matplotlib, the plot it is going to be like this: matplotlib. So the data is there from 2000 quarter one to 2012. So this is the data we have. So we will be predicting 10 quarters ahead of 2012. So in this problem, using ARIMA modeling, So to check to to know whether the data given is stationary or not. So there is a check called AD Fuller test. AD Fuller test, when we give the values to the AD Fuller, so it gives the parameters like statistics, ADF statistics, p-value, and the critical values. So to confirm that the data is stationary, the statistic value should be lesser than the critical values. That is the criteria to make it stationary. So when we do a basic when we do a check for a TS time series data, so we can see that the statistic is higher than the critical values. That means data is not stationary. Then we will be to make it stationary. We will be attempting the mathematical steps to make it stationary. So as a first step, I have applied the log properties. I have applied the log numpy log. I have applied. So ts log equal to np dot log of ts. So then again I have applied AD Fuller test. In AD Fuller test, the statistics again is higher than the critical values. So as a next step, I have applied moving average. I have removed the moving average from the log. removed the moving average from the log and calculated the AD Fuller test. AD Fuller test in this there is an improvement. There is an improvement in the statistic, but it's not as per the criteria. The statistic value should be lesser than the critical value. So this change does not given the effect. So let us do a differencing. So TS, so log differentiating. Let us do a log differentiating and apply AD Fuller test. So after applying AD Fuller test on a log differentiated data, it has given the statistic value is lesser than the critical value. Statistical value is lesser than the critical value. That means now the data is in stationary. That means it is ready to apply ARIMA or any other models in this data on this data. That means TS log diff is a stationary data. We can state that the TS log difference data is a stationary data. So what are the ways? What are the models we have? There are models like autoregression, moving average, autoregression integrated moving average. So here we made differentiation. That means we should go for a ARIMA modeling. So to get the ARIMA modeling, to apply a model, we need to find out values like P, D, Q. So D is here we have a first level of the order of differentiation. We applied here. That means D value is 1. So we need to find out the values for P and Q. P and Q values can be obtained. P can be applied from ACF and a PACF graph. So this is a ACF graph. In the ACF graph, P can be calculated. That means in the graph we could see at the value 1 there is a big change. Of value from from 1.0 to minus 1.6. That is the first big change. That means that instant can be calculated, can be considered as P, So same thing we could do it for calculating the Q value. That is using PACF graph. So PACF graph we could see here we cannot conclude any concludable value of Q. So the graph here is given like this. So in this scenario, what we can do is we can apply different values. So different values to ARIMA model, between the range of 0 to 5. So now we have values for D, that is 1, for P we have 1, that means we need to find out the Q. So let us apply different values to PDQ over a range and see what is the AIC values. So the criteria here is after applying different values of PDQs and we need to check for the AIC values. Here we could see in this scenario there could be a possibility that it cannot be converged. There are for some values of PDQ the model cannot make, some values of the model won't converge. So we need to take the PDQ values with a minimum with a AIC values. Here we could see here see 110 is converged. The 110 has been converged. So let us apply 110 here. Let us apply 110 here for ARIMA modeling and predict for next 10 quarters. Using this model. Quarters from 2013, we have data till 2012 fourth quarter. So let us predict for 2013 quarter 1 to 2015 quarter 2. That means 10 predictions we are doing. So after getting the result, we need to do untransform, and we did lot of transformation to make the data is stationary. So we need to untransform all the operations to get back the original data. So original values. So let us do untransformation here. After doing untransformation, this is the original data of the TS, and The prediction values also can be seen. The prediction value for the next 10 quarters, it is in the orange line. It is in the orange line, and the blue line gives the original data. So this in this way we can predict we can forecast the data of a time series. Basically, this is a univariant time series. We have only one column, and index for the column is the time. So in this way, univariant time series modeling can be applied using ARIMA modeling. Please share your comments in the comment section. Thanks. Thank you everyone.